Hi, in today's video, we are going to be talking about exploratory data analysis with pandas. The topic is visualization. Once you get the hang of it, Python syntax is really not that difficult. But what is difficult is to actually understand how to use the different kinds of visualizations. You can create any number of visualizations in Python very, very quickly. However, if you want to really be able to use them effectively in a presentation, for example, or when you have to derive some insight, it definitely requires a little more knowledge and insight about the charts themselves. So in today's video, I'm going to be talking about the charts. So why do we need to visualize data as part of EDA? So let's begin with that first. The first thing is it helps us understand the data distribution. That is to say how the data is spread out. I mean, is it a left skew, for example? Is it a right skew? These are all reasons why we would want to at least get a high level idea by just looking at it and visualizing. It's a quick summary. The second thing is to identify missing data quality issues. Another important thing which visualization can do is it can give you a sense of outliers in your data. Now, outliers can significantly affect the way your analysis and your algorithms. So it's really important to have some kind of thought process about treating outliers. Now, pandas visualization can easily provide you lots of really easy to chart tools such as box plots, which can help identifying whether there are outliers, and secondly, if they're really extreme, do they need to be treated or not. So, as you're beginning to see as I talk through it all, there is a lot of judgment involved in the entire visualization and exploratory data analysis process. It's not as simple as running code. The coding part is, in fact, the easy part. The third thing that charts can do is it can help you get a preliminary idea of what are the kind of patterns and relationships in the data. Seeing it visually really helps. You can run a big correlation table, for example, but you really won't be able to get a sense of things. There's nothing like seeing it presented in heat maps, in bar plots, in histograms to get an idea of what is the kind of patterns in the data. Effective visualization is also a very important part of finally communicating your insights and findings. In fact, any marketing PPT has got a large number of um, charts, etc. And these are really important to communicate out. So now that you've understood that visualization is important, and not only just learning how to generate the charts, but actually understand what they represent. Now let's just understand very quickly what are the libraries in Python that we can use for data visualization. The gold standard library is Matplotlib. This is foundational plotting library, and honestly, if you were to go to ChatGPT to ask for it to generate a chart, its chances are that it's going to use Matplotlib syntax. So yes, definitely it's a good idea to get familiar with Matplotlib. Matplotlib also has a huge number of customization possibilities. So you can really customize your charting area, your fonts, your titles, etc. So it really offers immense flexibility. Now, all this flexibility comes at a cost, and the cost is complexity of code. Matplotlib code just looks complicated. Actually, it isn't, but it takes time to get used to it. So if you're new to Python and pandas and struggling along, I would say give Matplotlib a skip for the time being. Now, instead of that, I would say go with Seaborn. Seaborn is another Python visualization library, And in fact, it sits on top of Matplotlib. But Seaborn provides a much simpler and higher level interface for creating attractive and informative graphs. Um, Seaborn also, so Seaborn offers most of the functionalities that Matplotlib offers, and it in terms of flexibility, customization, and chart types. And more importantly, it provides really simple syntax which anybody can figure out, minimal code. So I really recommend Seaborn as the library to get started with on visualization. Now let's deep dive into the charts. What do they mean? The first chart we're going to begin with is the histogram. Now, the purpose of a histogram is to show you the distribution of a single continuous variable. For example, we have a cholesterol variable plotted on the x-axis. So it gives different and on the y-axis, we have the frequency count. What a histogram does is it goes in, it splits a continuous variable into different buckets or ranges, as you can see over here. So it's 0 to 200, 200 to 300, 300 to 400, 400 to 500. So these are known as the bins. So, and then what it does is it counts the number of data occurrences which are falling into each bin category and plots these as a bar chart. Now, a histogram is really useful for understanding a couple of things. The first thing is it gives you an idea of the distribution of the data, as you can see, and whether it is looking approximately normal. Now, for many algorithms, having an approximately normal distribution is really important. All right, so that's one thing. Then second thing it can let you understand is that if your distribution, for example, is really skewed. If it's skewed, then again, you can, there's various things that you can do, which I will be telling you about in exploratory data analysis for, making the distribution a little more bell-shaped. And then, so you can get to see whether you have a left skew, right skew. It can also help identifying outliers. As you can see, there's some outliers here. So this at least gives you a first sense of identifying outliers. The second one which I come up with is a heat map. Now this is your workhorse representation. What it does is it takes all your continuous variables and plots them, calculates the correlation coefficient between them and plots them using a heat map. The higher is the correlation, that is towards 1, the more red the cell will be. The lower or more negative is the correlation, the less, the more blue it will be. So if it's -1, it will be a deep blue. If it is 1, it will be a red. And in between, you have various shades of orange and light blue. So it's really, the diagonals are not important because obviously a variable will be correlated with itself. However, off diagonal, what is important is to check the numbers which are looking a little large, because this gives you a preliminary idea that, for example, max heart rate is varying with old peak in a negative way. Or similarly, max heart rate is also negatively with age. So as your age increases, your max heart rate decreases. So these are all the different types of correlations that you can see. So a heat map is a really useful shortened summary, and you can derive a lot of insight from it. Now there is a plot called a pairplot, which is very popular in amongst data scientists. I personally feel it's a little overrated. Again, it's similar in concept to a heat map. However, instead of actually calculating the correlation coefficients, it essentially plots the scatter between all the different continuous variables and presents it as a matrix. So as you can see here, you have, say for example, cholesterol being plotted against age, then it's plotted against old peak and max HR, and finally against itself, and so on and so forth. Now, as long as the number of variables is less, I think it's not too bad. However, once you have a very large number of variables, this can become very unwieldy and can lead to tiny little graphs, and which may not add a lot of insight. The third important plot that we have is the box plot. Now this is an absolutely critical one, and I'm going to take a separate video on it because it's really important to understand. So right now, as of now, I'll just give it at a very high level. A box plot is basically a means by which we represent a continuous variable. Essentially, all the observations are plotted against on a box plot. Within the box range begins from the first quartile and goes to the Q3. The whiskers and all the points below it to the minimum value represent the whiskers, and similarly all the points above the third quartile and up to the maximum value represent the whiskers. Any point below and above the minimum and maximum value of the whiskers is defined as an outlier. So don't worry if it seemed a little superficial. I will be coming back to this one in another video. It's extremely useful for, again, identifying outliers, because here you can explicitly see the maximum value and you can actually calculate these outliers. And the second thing is it's very good to also see the distribution and skew. So this is yet another means by which we see the distribution. Now we come to more categorical data, and one of the important charts is a bar chart. It essentially shows you the, now in a categorical variable, what happens is you have a frequency count. For example, in this variable, the variable of arterial heart disease, no and yes. Now both these categories have to be charted, and the count of each of these is plotted. All right. So this is basically a bar chart and is extremely useful, and you can plot all kinds of categories, and you can also actually break up the categories by different categories, right? And lastly, of course, we have the good old scatter plot, which shows you the actual scatter between two continuous variables. Again, in this particular plot, it's called the joint plot. It shows you not only the histogram distribution of the individual variable, but it also shows you the scatter plot between the two. All right, so I'll stop here in this particular video, and in the next one I'll be picking up on the box plot deep dive and how we can then use it to identify outliers.